Hey guys, fancy meeting you here. Welcome to another fun edition of Patio Productions Pre-Calculus from Mrs. Fox's backyard. Thank you. We're going to continue our journey learning about limits today. Yay! And today we're going to take more of like a pictorial approach where they like to give you just like this little snippet and little picture of a graph, and they ask you all sorts of questions about it. Okay, and we're going to learn some fun like notation. Okay, and so that's what we're going to do for today. So let's get started here. Let's pull up our PowerPoint for today. So it's kind of the same title that we had before, except for it's just going to be day 2 today. Okay, so we're going to do a limit of a function, just day 2, and we're going to talk about some more notation and all sorts of good stuff like that. So I'm going to be super excited. Okay, so we're going to actually start with writing right away today. Okay, so sometimes x will approach a specific x value either from the right or from the left. Now, we had some fun songs. If I put them on, YouTube's going to flag me. So we had our favorite Beyonce song that we were singing, and it goes, instead of to the left, we said from the left. So from the left. Or when we're doing the right one, we said, all right now, baby, it's all right now. And then sometimes that's just what happens, okay? So we're going to either come from the right or we're going to come from the left. So this is kind of how it works, okay? So what's going to happen is you are going to have some sort of notation. We're going to talk about it in just a second. And it's going to say as x approaches, to from the left, okay? So that means you need to take your left hand and you need to put it over on the left-hand side. Do it with me. Take your left hand, put it over on the left-hand side, and then put this guy as your target value. So you're going to go to the left-hand side and you're going to come in towards the target value. Now, I completely understand that you are now traveling right, but that's what it means, okay? Then we'll put our other hand up and we'll go a little bit to the right of that. So we're saying all right now, over here. And then we're going to travel in and we're going to travel left to get to that target y value, okay? I'll try to explain that with my little writing. So sometimes when we come from the left or we come from the right, those y values are not going to match, and that is okay. I know, pretty exciting. So it just means as we get a different type of answer, okay? So let's take a look at this. So here's the notation that we definitely want to be interested in, okay? Let me get my pen here going, okay? This says the limit, but yesterday we had the as x approaches a, but check out this extra little piece of information right here, and check out this little piece of information right here, okay? So those two little things are of great importance to us. I'm actually going to undo those just like super quick, okay? So this says as x approaches a from the right, and that's what that little plus sign, it's almost like in the exponent spot, okay, but it's a plus sign, and then of f of x, and it's going to equal some number, and then we might have the limit as x approaches a, and then there's like almost like a negative symbol in the exponent spot, and it means from the left of f of x is going to equal some number. So the a to the plus sign means from the right, and those are the words that you say, the limit as x approaches a from the right. And then on this other guy, you say the limit as x approaches a from the left. And so again, you're going to think about your target value, and then you're going to be like, okay, I'm approaching it. Am I approaching it from the left-hand side? So you sneak a little bit to the left and then come into that target x value, or am I coming from the right, which means I go a little bit to the right-hand side and sneak in to the x target value, and then what's the resulting y value, okay? Just as a reminder, let me go back. Just as a reminder, this is an answer, and this is an answer, and these answers are y values, okay? Sometimes the y values match, sometimes they don't match. Let's talk about what happens when they do match, okay? If these two y values are the same, okay? If the limit, okay, if they are the same, we're going to say the limit as x approaches a from the right of f of x is going to equal the limit as x approaches a from the left of f of x, and that is L. Okay, so these two values are the same. You're going to say the limit exists at a, and then you're just going to say the limit as x approaches a, and you'll notice there is no superscript, no plus, no minus, of f of x equals L. It means it's coming from both sides, okay? And we had a fun song from that. I can't even sing it, but it's the from both sides now, okay? So when you don't have a plus or a minus, you just do it from both sides. And if those two y values are the same, boom, just like that, we say the limit exists, and it is that number. So the limit exists if they are the same. Okay, a special note. This is hard to accept sometimes, but I want you to write this down. The function may or may not have the same value as the limit at that particular x value of a, and that is okay. That is perfectly acceptable if the function value is something different from the limit value. Okay, so let's look at some questions and so that we can explore this so you'll be ready to rock for your homework assignment, okay? Here's just a random graph. There's a random graph. It's kind of like a piecewise function. There's this part of a line, and then there's an open circle, and then another part of a line, and then there's a dot right here at like 2,1, and there it is. That's what it says. Okay, so here we go. Part A of the question says, after you've copied this beautiful picture down, which I'm sure you did marvelously, I'm sure. I lost my pen, guy. Whew, there he is. Okay, so part A says, the limit as x approaches 2, and then there's the negative sign. So that means from the left, okay? So as x approaches 2 from the left. So, guys, sometimes when I'm learning how to do these, I like to think about what my target x value is. And sometimes I'll put like a dotted line. Okay, well, obviously this is a lovely dotted line. You're going to pretend like it's straight. But this is our target value of x equals 2. So if I'm approaching this target line from the left, that means I'm going to go over here to the left-hand side. I'm going to hop on the curve somewhere, and then I'm going to start inching my way in towards the target value. As I'm inching my way in, what y value am I getting closer and closer and closer to? Well, it looks like right here, 1, 2, 3, 4. The y value that I'm closer and closer and closer to is 4, and that is the answer. Okay, part B of this question says, what's the limit as x approaches 2? And then there's the plus sign as this sort of like the superscript. So that's from the right. So I still have my target value of 2. I'm going to go to the right of the function. I'm going to hop on to the curve, the line, and then I'm going to come in towards the target value. What y value am I heading towards? Again, I'm heading towards a 4, just like that. Okay, so now I have another question. What is the limit as x approaches 2? And so now it's from both sides at the same time. Now, I can't do this, but I can show you with my fingers. If you're coming in from both sides, okay, from both sides, folks, what y value am I coming in towards? Coming in towards a 4, okay? Because this answer right here of from the left, okay, so because the from the left answer existed and the from the right answer existed, and these two are the same values, we get to say that the limit exists and the answer is 4. Okay, now I have another question. What is f of 2? Okay, guys, where is the dot that is f of 2? It would be 2, comma, well, check it out. Here's where the dot is. It's at 2, comma 1. Okay, so guess what? That's a different math topic, but it doesn't matter, okay? It doesn't matter that the y value is not the same for f of 2 as the limit value. Those can be different. Isn't that the coolest? I know, it's pretty snazzy. Okay, so then I decided let's do a more complicated one. Woo! Okay, I don't know what these are pieces of graphs of. They could be parabolas or log graphs or exponential graphs. I don't even know, but they gave us this graph, okay? It should be noted, I'm sorry that's a little bit darker than usual. I took it off the side of my book page, so it's a little bit darker, but that's okay, guys. We're going to make it work, right? I mean, it's totally fine. We got this. Okay, it should be noted that on this graph that every tick mark is 2. So it goes 2, 4, 6, 8, and then -2, -4, -6, -8, just so you know, okay? So you're going to try to copy that down. And let's go ahead if we can answer some of these questions. So there's a whole host of questions that we're going to answer. So the first one says, what's the limit as x approaches negative infinity? Okay, so as x approaches negative infinity means I'm going to the negative infinity. So the x's. So I'm going this way and going this way and going this way, just like that. What y value am I getting close to? Number 1, it looks like there's an asymptote. Yes, it does. Okay, but what is that asymptote that it's getting closer and closer to? It looks like the y value, because remember, the answer to a limit question is a y value. Looks like a y value of 1. Okay, so the tick mark's at 2, so this would be a y value of 1, and so that is our answer. Okay, now before I get all confused, I'm going to erase that and let's try part B. Part B of the question says, what's the limit as x approaches -1? I want you to notice that there is nothing that says from the right or from the left. So we're just going to be approaching the target value of -1. Okay, where's the target value of -1? -1 would be about right here. So this is like my target value that I'm going in towards, okay? I'm going to have to hop on the curve from both sides. So I hop on the curve from the left side and I come on down. I hop on from the right side and I'm coming in. What y value right here are these guys coming in towards? It looks like right here. It looks like a 2. That's 4. So maybe like a -3 value. So it looks like that's going to be a -3 answer. Okay, let's erase all that. Here we go. Let's go to a part C question. Okay, part C says, what's the limit as x approaches -5 from the right? Whew, okay, -5 from the right. Okay, -5. So -5 is going to be here. This is my target value of -5. And it says from the right. So I'm going to go to the right of that spot. I'm going to hop on the curve on the right-hand side. And I'm going to come on in. What y value am I coming in towards? It looks like I'm coming in to a y value of 4. Just like that. So beautiful. Let's try another one. It says, what's the limit as x approaches -5 from the left? Okay, so this is different. Okay, let me erase. Okay, so my target value is still a -5 on the x's. Here it is, but we're going to jump on it. It says from the left. So I go a little bit to the left of this spot, hop on the curve, and then work my way up to the target value of x is -5. It looks like that is a y value of 7, just like that. Let's do a part E. What's the limit as x approaches -5? No from the right, no from the left. Just straight up, x approaches -5. Hey, folks, guess what? Because the from the right answer and from the left answer were not equal to each other, we get to say right here that it does not exist. And the notation that we use for does not exist is just the abbreviation of D and E. So please feel free to put does not exist. Okay, ladies and gentlemen, we are now going to talk about, so this is another example of picture. So in your homework tonight, you're going to have pictures. You're going to hop on the graph. I would suggest you put your fingers on the graph, use a pencil, you draw pictures, you put target value, just remembering that the y value is what you want for the answer to a limit question. Now, this next part right here can be a little bit intimidating. Yeah. Okay, here's the deal. We cannot be afraid of the notation in mathematics. We have to embrace it. We have to love it. So here's the deal. There is actually a precise definition for what a limit is, and we explore it in calculus. In fact, though, we don't really do much with it in a calculus course. If you were to major in mathematics and do some higher level mathematics, you would be doing these things called delta and epsilon proofs, where you try to prove calculus. It's fascinating and just super cool, but a little bit, above our pay grade. Oh, I didn't mean to put the applause. I meant to put this one. It's above our pay grade. And so what we're going to do instead is we're just going to expose ourselves to it. We're going to look at it. We're going to write it down. We're going to say, okay, I got it. Mrs. Fox is going to try to explain it in English after we write it all down, and then we're going to go from there. So what I want you to do is I want you to, just like we do in class, drop your pencil. Drop it. Drop it. Did you drop it? I hope so. Okay. Drop your pencil, and let me just present it first. Then we'll take up our pencils and we'll write it, okay? This is the idea of a limit, okay? You're not writing. Don't write, you guys. We're not writing right now, okay? In fact, we're just going to look real fast, okay? There's going to be a target x value. And you can see that they made like a little window on either side of the target x value, okay? This little window is going to, according to a limit, correlate to a little window around the target y value, which would be this guy right here coming in. This would be the target y value, and that there's a little window on either side. So this is what the limit definition, precise formal definition says. I'm going to read it to you and explain it to you. You still should not be copying. You still should just be listening, okay? It says the limit of a function f of x is L as x approaches a, denoted by this loveliness, okay, if you have a positive number epsilon, okay? So this is the limit if there's a little number, okay? How little is this number? However little you decide, it doesn't matter. That there's a little number where you can make a little window, a little like window on either side of the y value, that will correlate to a little window on either side of the x value. This is what the definition of a limit is, okay? Once again, if there's a little window on either side of the y value that's going to correlate to a little window on either side of the x value. And if you can put that, if you can make such a little window and define it, boom, that's what it means to be a limit. And the window is with teensy values, like 0.001 or something like that, something super teensy, but you can make it as teensy as you want. Let's go ahead and draw this picture and write down the words, okay? The words go like this. You can pick up your pencil now. Thank you for being patient. Thank you for being patient. Let's pick up our pencils and let's write this part, okay? It says, the limit of a function f of x is L. The limit of a function f of x is capital L as x approaches a. As x approaches a, denoted by the limit as x approaches a, x arrow a, of f of x equals L. So limit as x arrow a, x approaches a, of f of x equals L, comma, if for any positive number epsilon. This is a lowercase Greek letter right here. This looks like a backwards 3. It's called an epsilon, okay? So if for any positive number epsilon, however small, there is a positive number delta. This right here is a lowercase delta. A capital delta looks like a triangle. You guys know that, okay? But that's a lowercase delta. It looks like a fancy D that has like a little hook on it. It looks like that. It's a delta. That was a really bad job, okay? There is a positive number delta such that the absolute value of f of x minus capital L, close the absolute value, is less than epsilon whenever 0 is less than or equal to x minus a, absolute value, which is less than delta. Again, the limit means there's a tiny window around the y value that correlates to a tiny window around the x value where you can find that actual number. That's it. Folks, you're not memorizing this. You're not being tested on it. I need to expose you to the notation for the beauty that it is, okay? So that's it. That's all we're going to do with that. You wrote it down once. You should feel accomplished. Here's your homework assignment, folks. You're going to go back and you're going to practice some of the more graphical ones. So on our previous assignment, we did more algebraic and like looking at a graph like on Desmos. Now we're going to be more pictorial where you're like coming in from different ways. We're talked about from the right and from the left and all that good stuff, okay? So that is our lesson, okay, for today. Let's get back to the recording. Ladies and gents, that's our lesson, okay? I think you're going to have a good time. Only 14 questions for homework. We're still doing the same things we're always doing, taking a picture, uploading it, doing all that jazz. I really, 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 really hope that you guys are staying on top of these things. Chapter 16, super important to lay the foundation, especially if you're going into a calculus course, either next year at LaSalle or maybe in college. So I think that's it. All right, I'll send you off with our fanfare music. I hope you have a wonderful day. Enjoy the homework. Come see me in office hours if you have questions. Bye.